This video tutorial will take a look at the Pythagorean theorem and radicals. We are going to use the Pythagorean theorem to determine the missing side length of this right triangle. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the right triangle. In this example, the legs of the right triangle are the square root of 5 and the square root of 7. We will substitute these values in for a and b in the Pythagorean theorem. It does not matter which one goes for a and which one goes for b. In the Pythagorean theorem, c represents the hypotenuse, which in our example is x. So we will substitute x for c. Now that we've substituted the values into the Pythagorean theorem, we can simplify the exponents. First, we will do the square root of 5 squared. Let's break this down. The square root of 5 squared is the square root of 5 times the square root of 5, which equals the square root of 25, which is 5. So the square root of 5 squared is 5, which will be added to the square root of 7 squared, which is 7, because the square root and the square cancel one another out, leaving us with just 7. Now we can do 5 plus 7, which is 12. To get x by itself, we need to undo the square. We will do this by square rooting x squared. What we do to one side, we must also do to the other side. The square root of x squared is x. And because our side lengths have been left as square roots, we will also leave our hypotenuse as a square root. So we will leave this as the square root of 12. But this can be simplified because our radicand, or the number inside the square root symbol 12, has a perfect square factor. The square root of 12 can be broken down into the square root of 4 times the square root of 3. We do this because 4 is a perfect square and can therefore be broken down further. The square root of 4 is 2, and the square root of 3 cannot be broken down any further. So we are left with 2 times the square root of 3. This is our final answer for x, and x represented our hypotenuse. So the measure of the hypotenuse is 2 times the square root of 3. Let's try another similar example. We will use the Pythagorean theorem a squared plus b squared equals c squared to determine our missing value. In the Pythagorean theorem, a and b represent the legs of the right triangle, which in this example are the square root of 10 and the square root of 8. We can substitute these values in for a and b in the Pythagorean theorem. In the Pythagorean theorem, c represents the hypotenuse, which in this example is x, so we can substitute x in for c. Now that we have substituted these values into the Pythagorean theorem, we can simplify our exponents. The square root of 10 squared is the same as the square root of 10 times the square root of 10, which equals the square root of 100, which is 10. So the square root of 10 squared is 10, which will be added to the square root of 8 squared, which is 8 because the square root and the square will cancel one another out, leaving just 8. We can now do 10 plus 8, which is 18. We need to get rid of the square to get x by itself. To do this, we square root x squared. What we do to one side, we must also do to the other side. The square root of x squared is x, because the square root and the square cancel one another out. And we are going to leave our answer as a radical, the square root of 18. This can be simplified though because our radicand, 18, has a perfect square factor in it. The square root of 18 can be broken down into the square root of 9 times the square root of 2. We do this because 9 is a perfect square. The square root of 9 is 3. And we leave the square root of 2 because it is simplified. So our final answer is 3 times the square root of 2, which is our value for x, which represents our hypotenuse.